Good evening, GCC, College Algebra. We're going to be finishing up Chapter 7 here, Chapter 12 here. There's 2 sections left, 7 and 8. And in both of these, we're going to talk about systems of inequalities. So far up until now, everything's been about systems of equations. And when we've solved them, it's all about the point or points of intersection. But with systems of inequalities, it's going to be a little different. There could be a whole range of different answers. All right, so first, let's take a look at an inequality. Do we remember what that is? So let's look at a linear inequality. A linear inequality, an inequality that's represented by a line. For example, 3x plus y equals 6. Well, actually, that's an equation, right? So if I want to make it an inequality, I'm going to say less than or equal to 6. Now it's an inequality, a linear inequality. If it was equals, it would be a line, but it's an inequality here, so a linear inequality. And I want to solve this. I want to graph this linear inequality. Now, we graphed these before, and I kind of hinted way back when at what a system would look like. And we put one on the board and kind of briefly talked about it, but we really didn't do much with them. Well, here's where we're going to do a lot. Here we're just going to look at systems, and then in 12.8, we're going to actually create the systems that we're going to graph. Here they're going to give them all to us. So if I want to graph this inequality, first thing I want to do is, how can I graph this? Well, remember, there's 2 tricks. I could use the intercepts trick. When y is 0, that disappears. Divide both sides, and I get x is 3. When x is 0, that disappears. Divide, and I get y equals 6. So I could graph it that way, or I could put it into y equals mx plus b form by subtracting 3 from both sides and getting y's less than or equal to negative 3x plus 6. And it doesn't matter which way you do it. Whichever way is easier, whichever way you want to think about it. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. 3, 4, 5, 6. 4, 5, 6. Remember when we started this chapter, and the first method of solving systems of equations was by graphing, and we talked about that the solution would only be as accurate as the graph. And if you had graph paper, that would be a probably good time to bring it out. Same thing here. Our solutions to these inequalities are only going to be as good as your graph. So if you have graph paper, go ahead and take it out. All right, so let's see. I'm going to use the intercepts method. So again, if y is 0, x is 3. Where is x is 3? Right here. And if x is 0, y is 6. Where is 6? 1, 2, 3, 4, 5. Here it is. Now, before I graph the line, do you remember we have to take a closer look at the sign? If it's not or equal to, we use a dotted line. If it is or equal to, we use a solid line. This one says or equal to, so I'm going to use a solid line. And I want y values that are less than or equal to the line. So I'm going to shade below. Less than means I shade below. There's the inequality. Now, if you can graph one inequality, you can graph a system. Remember me saying that way back when. But let's take a look at a non-linear system. I'm sorry, a non-linear inequality. A non-linear inequality would be something like x squared plus y squared is less than 4. All right, so what is this? X squared plus y squared. Well, we saw it a little bit earlier in this chapter. We've seen it in previous chapters. It's a circle. It's a circle centered at the origin, with a radius of the square root of 4 with a radius of 2. So I'm going to graph this. I've got a circle centered at the origin with a radius of 2. So centered at the origin, I'm going to go 2 this way, and 2 this way, and 2 that way, and 2 this way. So the center is the origin right here, 0, 0. And then from that center, I'm going to go 2 to the right, 2 up, 2 left, and 2 down, and then I'm going to connect the dots. But before I do, am I going to use a solid line or a dotted line? This is not or equal to, so I'm actually going to use a dotted line here for my circle. Oh, that's not a very good circle, is it? Now, if I had graph paper, it would probably be a little bit better. So now what about the shading? Well, I want these less than 4. Less than 4 would be all the points inside the circle. So for shading, I'm actually going to shade everything less than 4 inside the circle. All right, let's take a look at another one. How about y's greater than or equal to x squared? This is a non-linear inequality. If I go to graph it, x squared, I know what x squared is. X squared is my nice, well-behaved parabola, parent function of the parabola. If x is 0, 0 squared is 0. If x is 1, 1 squared is 1. If x is 2, 2 squared is 4. If x is negative 1 times negative 1 is positive 1. If x is negative 2 times negative 2 is positive 4. There's the parabola. We can see the shape of the parabola there. Solid line or a dotted line? Oh, it's or equal to, so solid line. There's my parabola. But I'm not done because it's an inequality. Y is greater than the parabola, bigger than the parabola, which would be all the stuff inside there. If it was less than, it would be on the outside. All right, let's take a look at a couple more. And as you can see, we're doing these kind of one at a time. And in a minute, we're going to talk about systems. And a system is really just doing 2 or more of them on the same graph. How about this one? Y's less than 2. How would we graph that? If it looks and feels a little familiar, it should. We've done these before. Y's less than 2. Here's where y equals 2. In fact, that whole line right there is y equals 2. But I want a dotted line because it's not or equal to. And I want values less than that. Less than would be below. How about x is greater than or equal to negative 3? Again, this should look and feel a little bit familiar. 1, 2, 3, 4, 1, 2, 3, 4. Where is x negative 3? There it is. So I'm going to have this vertical line here. Solid or dotted line or equal to means a solid line. And I want x's that are greater than negative 3. Which side is that on? This side right here. And we should remember y equals 2 is the horizontal line. X equals negative 3 is the vertical line. And then I'm just doing solid or dotted lines. And which side am I shading? So that's quick inequalities, which we've seen those and done those before. Now, and if you can do that, then you can do systems. Because all a system of inequalities is two or more inequalities on the same graph. So let's take a look at a system of inequalities. How about x plus y is greater than 2 and 2x minus y is greater than or equal to 4. So now, as I take a look at these two inequalities, this is a system. If these were equal signs, this would be a system of equations, equalities. But there are inequalities here, so this is a system of inequalities. I want to graph both of them on the same graph. Let's take a closer look at them. First, the first one. X plus y greater than 2, subtract x from both sides, y greater than negative x plus 2. That's going to be the first line. I'm going to have a y-intercept of 2 and a slope of negative 1. The second inequality, 2x minus y greater than or equal to 4. Subtract 2 x's from both sides. So I subtracted the 2x. Divide by y. Oh, now watch out. Remember this? Do you remember with inequalities, whenever we multiply or divide by a negative number, we have to flip the sign. Negative 2 to 2x, and 4 divided by negative minus 4. So the two inequalities in nice, well-behaved format are this one and this one. That's what I want to graph. So I'm going to graph them on the same axis, on the same coordinate. 1, 2, 3, 4, 1, 2, 3, 4, 3, 4, 1, 2, 3, 4. All right, so the first one is y is greater than the line negative x plus 2. The y-intercept is 2. The slope is negative 1. Rise 1, rise negative 1, run 1, rise negative 1, run 1, or rise positive 1, run negative 1. There's my line. Solid or dotted line? Dotted line. And am I going to shade above or below that line? Y value is greater, I'm going to shade above. The other line is, let's see, do I have a nice different color here? Let me see if I can use green on this one. Y is less than or equal to the line 2x minus 4. Negative 4 is the y-intercept. 1, 2, 3, 4. There it is. The slope is 2. Rise 2, run 1. Rise 2, run 1. Rise 2, run 1. There's my line. Solid or dotted line. Less than or equal to solid line. And shade above or below. I want y's less than that, shade below. So now notice what's happened here. When we graphed both inequalities on the same axis, we actually ended up with 4 different regions. 4 different regions. Can you see them? I've got, let's see if I can use my highlighters here to help us out. I'm missing one of my highlighters. Excuse me, a bit of a cough. So I've got this region over here, I'm going to call it region A, which is right here, and region A is not a solution to anything. Up here I've got region B, C, and D. Oh, it's not very good. Let's see, I thought I had a yellow Sharpie somewhere, don't I? There it is, there it is. So let's try this again. Region A, region B, region C, and region D. There we go, that's a little bit better. So the solution to this system of equations, in a regular system of equations, the solution is the point or points where the lines intersect. But the solution to a system of equations is the region where everything is shaded in. So the solution to this system, I'm going to use my orange Sharpie here, it's either going to look cool or I'm going to really mess it up here, is this region right here, where both of them are shaded in at the same time. That's the solution. Region D, this is the solution, because all of the points in here are solutions to both inequalities at the same time. So that's my solution set. That's what I'm interested in. Region B is a solution to one of them, but not the other. Region C is a solution to the other one, but not the first one. Region A is not a solution to anything. None of the points in A solve either one of those. But all of the points in region D satisfies both inequalities. All right, so there we have it, ladies and gentlemen. That is a system of inequalities, the graph of a system of inequalities, and shaded, the solution represented there. Now, will we always have 4 regions? No. Some weird things can happen, even with lines. When we get into non-linear stuff, we could see something like, for example, we could have a parabola that's shaded on the inside of it, and then we could have a line that's shaded below. So now as I take a look here, a parabola shaded inside and a line shaded below, where is my solutions? My solution is only in the region where both of them are shaded at the same time. I'm trying to color without going outside of the lines here. There we go. That's a solution. How many regions are there? Well, there's this whole region down here, which is a solution to the line but not the parabola. This region up here, which is a solution to the parabola and not the line. These 2 regions here and here, which are not solutions to either one of them. So we might see 1, 2, 3, 4, 5 different regions, of which only that one, where the double shaded is the solution. What about just 2 lines? Well, what if I had this? What if I had a system that looked like this, where I've got one line right here, and I'm going to shade above this line, and then I'm going to have another line that's parallel, shaded below that line. Now what happens? How many regions do you see here? 1, 2, and 3. Region A is a solution to this line, but not that line. Region C is a solution, all the points in here are a solution to that inequality, but not this one. And region B is a solution to nothing. None of the points in B are solutions to anything. Here I've got 3 regions, and there's no solutions to this system of inequalities. There are no points that are double shaded. If I had a system that looked like this after I graphed it, there would be no solutions. There's nothing there. Typically, when we see 2 lines, we see them intersecting, and then we see areas where it's double shaded and areas where it's not. All right, these things will get more complicated the more inequalities that we add. So let's take a look at a tough one. I want to graph the system. And I'm going to have x plus y is greater than or equal to 3. And 2x plus y is greater than or equal to 4. And x is greater than or equal to 0. Y is greater than or equal to 0. So now in this system, I've got 4 inequalities. And I want to graph all 4 inequalities on the same graph, put all 4 of them on the same graph, and identify the shaded region. All right, so it's not as bad as you think. If you can graph one, then it really should be easy. We're just going to graph a whole bunch of these. So here we go. So let's see. 1, 2, 3, 4. 1, 2, 3, 4. I noticed that for, I think I'm going to run out of colors here, but for this inequality, I'm going to graph it using my x and y intercepts real quick and easy. When x is 0, the y-intercept is 3. When y is 0, the x-intercept is 3. All right, so am I going to join them with a solid line or a dotted line? Am I going to shade above or below? It's or equal to, so a solid line, y is greater than, shade above. So my line is going to look like this, and I'm going to shade above. Next line, 2x plus y equals 4. All right, so when x is 0, that disappears. Y is equal to 4. Here it is. When y is 0, that disappears. Solve for x. Divide both sides by 2. X is 2. Here it is. Those are my x-intercepts and my y-intercept. Am I going to use a solid line or a dotted line? Shade above or below? This is going to be a solid line because it's or equal to. Shaded above. And shade above means it's going to be now if I just ignore those last 2, I've got my classic example here of a region where things are double shaded. Remember this would be better maybe if I just kind of emphasize that it comes off the red line there. I've got this whole region over here that are no solutions. I've got this little region in here that's a solution to the red but not the green. And then, you know what, just to keep track of them, I did this one in red. I did this one in green. Hopefully the colors are showing up as good on your videos as they are on mine. And then here I've got solutions to the green but not the red, and here I've got solutions to both, which would include over here and over here. But wait, I've got 2 more. I want x's greater than 0. What would x is greater than 0 look like? X is greater than 0 means that I can only have positive x values. Well, positive x values would be here. Y is greater than 0. Positive y's would be here. Oh my goodness, what a mess. What a mess, what a mess, what a mess. So what is the solution? The solution, and I'm going to just extend the axis here a little bit. I probably didn't do the axis far enough, and the axis here a little bit. The solution is going to be, this is, if it was in class, I could turn the chalk sideways, and this would be a lot nicer and prettier. But the solution is going to be again, I'm trying to color and stay inside the lines. The skill we learned as kids, right? Coloring and staying inside the lines. Here's where we need it. Wow, that silver really kind of pops and kind of dominates everything, doesn't it? Yep. So I noticed that I'm going to use the black pen here, and I'm going to emphasize the boundaries of my region. Here it is. There's the boundaries. Man, that silver is even stronger than the black. You can't really see the silver unless you put it over a color. It's hard to see the silvers over here and over here. But boy, it just jumps right off the page with that purple, with that orange here. And of course, there is no boundary here. It keeps going on over here and over here and over here. It keeps going on. There's the solution to this system of equations. The x is greater than or equal to 0, I did in silver. The y is greater than or equal to 0, I did in silver. We're often going to see these two constraints here. X greater than or equal to 0, y greater than or equal to 0. And in the future, we're going to interpret these two as meaning first quadrant only. X greater than or equal to 0, y greater than or equal to 0 means everything's going to happen in the first quadrant. X's are positive, y's are positive. These two inequalities right here, x greater than or equal to 0, y greater than or equal to 0, means that everything happens in the first quadrant. Ooh, I went over the line a little bit. Oh dear. But that's what these two inequalities mean. These two inequalities mean first quadrant only. And that's what I tried to emphasize here with the black quadrant lines and then the lines right there. All right, so in the homework, you're going to see the homework is going to be in 4 different sections, 4 different skills. So I want you to go ahead and do assignment 12.7. Homework 12.7. It's on page, starts on page 944, but all the problems that we want to do are on page 945. And I want you to do, you're going to do, let's see, 11, 15, and 19. And these will just all be graphing an inequality. A single linear inequality. Nice, well-behaved linear inequality. And then I want you to do 23, 27, and 31. These are graphing a system of linear inequality. And then I want you to do 43 through 51 odd. So 43, 45, 47, 49, and 51. So 5 problems. And these are also graphing systems. But this is a little different. Graph a system of linear inequalities. But here there are going to be 4 of them. And a lot of times we'll see that x greater than or equal to 0, y greater than or equal to 0. Here's the textbook if you want to take a quick look at it. And I've circled the problems that I want you to do. So up here, just graphing a simple basic inequality. Over here, graphing a system. Here, graphing like this 45, I want you to do this one right here. X greater than or equal to 0, y greater than or equal to 0. That means you're just going to be graphing first quadrant. And you'll see that in all 5 of the problems that I've assigned you to do. So the answers are, the graphs are in the back of the book. You can look at them from there. But go ahead and try them. Write them down and then graph them. You can do these on the calculator too. The calculator will do graphing inequalities. It's relatively simple. Take about 8 to 10 minutes to explain, but it's not something we would ever really need to do. Most of the time we're going to be in fact all of the time in this class, we're just going to graph them by hand. In the last section of this chapter, 12.8, it's something called linear programming, but it's all about graphing linear inequalities. The big difference is it's a word problem, and you have to come up with the inequalities. And then once you've got the inequalities, you graph it, and then you look for the solutions in the feasible region. All right, ladies and gentlemen, there we go. We'll talk more about that later. Go ahead and do 12.7, and as always, as soon as you get it done, email it to me. Thanks, guys. Talk to you again soon. Bye.